for week 13. We're going to talk about area of a triangle. So here I have one case of a triangle, which would be our right triangle. This one's just easier to start with. Right angles always kind of make area easier. We have a right triangle. We don't have a formula for that yet. You might know it, but I'm going to pretend like you don't. We want to find the area of this triangle, and we will usually be given the base and the height, which have to be perpendicular to each other like we saw in the parallelogram. So base and height. Here is a triangle where I already had measured, and those are our numbers for all of the week, right? 10 and 7. We have this triangle. And just like all the other cases, we want to turn this into something we know the formula for. So I'm going to cut this triangle in half, and I already kind of have the line on the back that shows that halfway mark. So I'm cutting the height in half. So this was 7. Oops, sorry. I have this triangle. I cut it in half. So that means the 7 turns into 3.5, and now I have this long rectangle, right? And now I have 3.5 centimeters as its height. So we cut the triangle along the halfway mark of the height to get our area, which would be 3.5, because that's the height of this rectangle, times 10. So we get 35 square centimeters. Centimeters squared. Sorry you can't see that in the glare. All right, that's how we would do it, by breaking the triangle into pieces. So we can add that for our triangle. All right, we have area equals 1/2 base height. All right, we just usually like putting our letters in alphabetical order, even though in my example we cut the height in half. We do put B first just because we like it in alphabetical order. Another way to visualize this is, what if we had a rectangle that had the same height and base of our right triangle? So here we have that rectangle where the base of the rectangle is 10 centimeters and the height is 7. So instead of having a triangle, we have a big rectangle, which has the area of 7 times 10, so 70 square centimeters. But to get the triangle that we really want, we then cut this in half, right? So we would take that area and divide it by 2, and we would still get 35 centimeters squared. So we can kind of see this in two separate ways. Either, right, we have our triangle and we divide the height into to make a smaller rectangle that then has the same area of our original triangle. Or we can take a rectangle that has the base times the height, the same base and height of the triangle, that then we then cut in half, right? We have this rectangle of 70 square centimeters, and then we would cut it in half, and each of these would have an area of 35 square centimeters. And this one matches the triangle that we started with. So that is our formula for triangle. It's 1/2 times base times height. That's a right triangle. Here is a non-right triangle. And now here we can see we have base still, and we have the height, which is perpendicular to the base, but now that height is inside the triangle. It's no longer a side of the triangle, it's inside. And you might have situations where they draw it instead of like this. You would have a very obtuse triangle like this, where the height is actually outside of the triangle, and then the base is only from one corner of the triangle to the other. This is the base. This is not part of the base. Right? So I just wanted to give you that example, but let's go back to our non-right triangle where we have the base and we have the height. So, right, here's that triangle that I had measured. I tried to keep all my lengths and stuff the same. So 10 centimeters is the base. The height is 7 centimeters. So it's the same base and height of the other triangle. But we have a different looking triangle with the same base and height. Just trying to get the glare to disappear. Okay. Sorry for spending so much time just trying to focus. All right. One more time. Okay, well, we're just gonna have to settle for a blurry video, I guess. It has it, and then it just doesn't keep it. Okay, we have this triangle. We're gonna do the same thing as we did with the last one. I'm gonna cut it in half, halfway through the height. All right, so here I cut the height in half. And then I'm going to move it around, and now I get a parallelogram. And we know the area for a parallelogram, right, is base times height, but I divided the height in half. So here I'm going to have that 3.5 times 10 again. So that 35 centimeters squared. All right, so again, we had our original triangle. It wasn't a right triangle, so the height wasn't one of the sides. Instead, it was inside the triangle. And then I cut it in half along half of the height. I rotated it to get that parallelogram that then has a height of 3.5, so we can do it that way. Just like with the right triangle, we could have a parallelogram that has the same base and height. So here we would know the area of the entire parallelogram is 7 times 10, or 70. But then to get that original triangle, we would then cut it in half. So then I would divide that 70 by half as well to get 35 centimeters squared. So that means, all in all, if we go back to that original non-right triangle, the formula for it is the same as for a right triangle, where its area equals 1/2 base height. I just wanted to kind of give you this visual so that way we're not just making these formulas up. We can actually have some reasoning and visual explanation about where we get these formulas from. All right, so good luck on all Khan Academy. I have 2 more videos for you to watch, but this is the halfway mark of the week. So you should have watched both of these before the first class of week 13.